Hello everyone, myself Mehak and today we will be viewing 3 exciting demonstrations that are in front of you. The first one being paper chromatography. The apparatus required for this simple demonstration is presented in front of you. You will require a few tissue papers cut in this shape, a transparent container which is already filled with water, as water is to be used as a solvent. Instead of water, other solvents that can be used are acetone or alcohol. Alcohol and water can also be used as a mixture for a solvent. Your sample can be any food color. Here I will be using the green food color. Another sample can be your blue marker pens or any marker pen that is available. You will require a scale and a pencil to mark the starting point of your solvent front and the final point it reaches after the capillary action is complete.
The first step in our demonstration is to fill a transparent container with our solvent, that is water. Make sure that the depth of the water is only as much as half a centimeter. The next step is to cut out our tissue paper in rectangular shapes like these. After that, we will make a parallel line from the bottom of the tissue paper. The parallel line should be drawn at a distance of at least 2 cm from the bottom. Have a closer look of the line. At the center of the line, I have made a point. At this point, here is where we will place the sample. The next step is to keep your sample ready. The sample, if in a solid form, has to be diluted with water. After we have dissolved our sample in water, the next step is the spotting step. For the spotting step, you take a little bit of the sample on the pencil and then gently add your sample on the tissue paper. Just a point. As you can see here, we have added our green pigment on the tissue paper.
Now that our sample has been added to our tissue paper, we come to the fun part, watching the sample rise by capillary action. Let's add our tissue paper to a transparent container containing a solvent, that is water. Make sure you are very careful during this step and do not add the complete tissue paper in water. The basic principle behind all chromatographic techniques is that in a mixture, the two compounds, one of the compound will be attracted towards the mobile phase, hence it will move up with the mobile phase, whereas the other compound in the mixture will be more attracted towards the stationary phase, hence it will stay back. Using this principle, the compounds appear to be separated on the tissue paper, as we will observe further. Our next demonstration is the second law of thermodynamics. There are 3 laws of thermodynamics, out of which today we are going to study the second law of thermodynamics. Have a look at a simple apparatus that consists of a plate, a few ice cubes, and our surrounding, which is readily available to us anytime. In thermodynamics, we first need to understand some terms. System. Our system over here is the ice cube. The boundary of the system is the edge of the plate and the surrounding. Any environment that surrounds our system becomes the surrounding. Here, our surrounding will be the room. Our system, which consists of the ice cubes, are at 273 Kelvin, 0 degrees Celsius. Our room is at the 298 Kelvin temperature, which we will consider the room temperature. Heat is a form of energy related to the movement of atoms and molecules. The amount of heat energy or the amount of motion of its particle is measured by a body's temperature. The second law of thermodynamics states that heat energy always moves from a warmer area to a cooler area and never in the opposite direction. You would not expect the ice cube to lose heat to the water and get even colder. That would violate the second law of thermodynamics. Towards the finishing line, we have the ice cube race. This has to be one of our most colorful demonstrations yet. Through this demonstration, we are going to study how the difference in color affects the absorption of sunlight by these papers. This difference will be observed as we will be placing ice cubes on these different colored papers and placing them in the sunlight. You will see that the speed of melting varies in each color. Light is a form of energy. An object that absorbs lots of light is taking in lots of energy. Some of that energy gets changed from light into heat. Remember that black objects absorb all the wavelengths of light. So, a black object, like a piece of paper in the sunlight, is absorbing a lot of energy and producing lots of heat. A white paper, on the other hand, reflects all the wavelengths and absorbs none. So, it does not have enough energy stored to create very much heat. Left in the sunlight, the black piece of paper absorbed more energy and became warmer than all the other pieces. It was observed that the ice cube on the black piece of paper melted the most and the cube on the white paper melted the least. This is the reason why you are recommended to avoid wearing darker colors during summer and are advised to wear lighter shades such as blue, white and yellow instead. Can you now guess which color wins the race? Thank you for watching the video. Wishing you a great day ahead.